Hello everyone, welcome to my channel. This is Jess. So today we'll be looking at a problem called merge intervals. So first off, let's take a look at the problem statement. You're given an array of intervals where intervals I equals start I, end I. This means the intervals contains a bunch of arrays, and each array has this start I and end I to specify this is an interval. And we're asked to merge all overlapping intervals and to return an array of the non-overlapping intervals that cover all the intervals in the input. So let's take a look at an example. Say if you're given this intervals array, and it contains 1 to 3, 2 to 6, 8 to 10, and 15 to 18. And the output for this intervals is going to be 1 to 6, 8 to 10, 15 to 18. Because 1 to 3 and 2 to 6 are overlapping, so we're basically merging them and then returning 1 to 6. And then 8 to 10 is not overlapping with anything, so we add that to our output list, so as 15 to 18. So to break this problem down a little bit, you're basically looking at a bunch of different intervals, and you're trying to figure out whether or not two of them are overlapping, and if they are overlapping, we then just merge them and then put them in the result list or the result array. So to simplify this question, we could think of it as if we're comparing two different intervals and trying to figure out whether these two are overlapping. Say if we're comparing interval A to B and interval C to D. One of the possibilities of these two being merged together, or like between the relationship of these two different intervals, is that A and B contains the intervals C and D in between. So C, the starting point of the second interval, is going to be in between A and B, as well as the endpoint of the second interval D. And another possibility is that C is still going to be in between A and B, but the endpoint of the second interval is going to be larger, or like after the endpoint of the first interval B. And another possibility would be A and B, and then something something C and D. So these two intervals are not overlapping. And these three are the possibilities when the starting point of the first interval is less than the starting point of the second interval. So let's consider the reverse. When the starting point of the second interval is greater than the starting point of the first interval. Similarly, one of the possibilities would be C and D contains A and B. Another one would be C and D, and then A is in between C and D, but B is after the endpoint of the second interval, which is D. And another one would be C and D, something A and B. So they're not overlapping. And let's think about if we're trying to merge, or like if we're trying to see what merged or non-overlapping intervals that we're inserting into our output array would be after comparing these two intervals. So for the first scenario, since A and B contains C and D in between, so we know once they're merged, the output is just going to be A to B. And for the second scenario, since C is in between A and B, but D is after B, so the output is going to be A to D. For the third scenario, since they're not overlapping, so if we're putting them into the output array, it's just going to be two different intervals, A, B, C, and D. For the fourth scenario, similarly, it's going to be C and D, and fifth one, similarly, C to B, and the last one, also similarly, C, D, A, and B. And from this graph, we can see that on the left-hand side, scenarios 1 to 3, these three scenarios are based on one condition, which is when the starting point of the first interval is less than the starting point of the second interval. And on the right-hand side, scenarios 4 to 6, those three scenarios are based on the condition when the starting point of the second interval is before or less than the starting point of the first interval. So let's think about if there will be a way to actually simplify this situation a little bit. Say if we're just taking the intervals input as is and try to process all the intervals in this intervals array and then try to merge all the overlapping ones and then getting all the non-overlapping intervals into the output array, there could be a chance where, for example, if you have 1 to 5 and then A to 15 and maybe some other stuff in the output array, and then you want to see where to put this current interval, which is 2 to 17, then there will be this chance where you have to loop through again all the already computed intervals in your output array to try to see where this new interval fits. And that's going to increase our runtime, and we don't want that. So one way to solve this problem and to simplify all these scenarios a little bit is we could sort those intervals before looping them and trying to see which ones are overlapping with which ones. So once we have sorted all the intervals in this intervals array by the starting point of each interval, then we will not have to consider the scenarios on the right-hand side where the second interval's starting point is less than the first interval's starting point. So all of the scenarios that we need to consider are the first three scenarios. And in this way, we don't have to go over all the already computed intervals in the output array. We can just loop through all the intervals that are already sorted and then either update the endpoint of the last element in your result list or to add the new interval into the output array. To further simplify the situation a little bit more, say if A to B is our output interval, so this is the interval that's already in the output list, and it contains the intervals from all the previous intervals. And this is the current interval that we want to find a spot for it. In the first scenario, since C and D is in between A and B, and we can see that the result is not changed, so we can basically ignore this situation because it doesn't modify our output interval. And in the second scenario, we are modifying this output interval, which we basically just changed the endpoint of the output interval and updated it to the endpoint of your current interval. And in the third scenario, since the output interval and the current interval are not overlapping, what we need to do is to add this current interval into our output intervals list. And there you have it. We now can start actually coding this solution out. So first thing first, what we need to check is to see if the input is valid. So if not, we just basically return an empty list. And then we'll need to sort our intervals input. And then we'll need to create this result list. And At first, we're going to put the first element in this sorted intervals list into our result just to start with. So intervals 0. And then we can loop through all the elements in the rest of this intervals list. So for I in range, we're starting from the index 1 because we have already put the first element into our result list. We don't want to compare it again with itself. So we're starting from index 1 and then to the length of intervals. The first scenario that we're going to consider is when the starting point of your current interval is in between the starting point and the ending point of the last element in your result list. So if intervals, the current interval's starting point is less than or equal to the last element in your result list, the ending point of that, and the ending point of your current interval is greater than the ending point of your last element in your result list. Then we need to modify the ending point of the last element in your result list. It's going to take your current interval's ending point. And another scenario that we need to consider is when the two elements, your current interval and the last element in your result list, are not overlapping. So if your current interval's starting point is greater than the ending point of your last element in the result list, then we basically just append your current interval into the result list. And for the scenario when your current interval is in between, like the total interval is in between the last element in your result list, then we don't need to modify anything, so we're basically just ignoring it in this case. And at the end, we want to return this result list. Oops, intervals. So now let's think about the runtime and the space complexity for this implementation. For the runtime, since we're sorting the intervals at the very beginning, and sorting, it takes n log n, n being the number of intervals in this intervals input. And after that, we're basically just looping through the intervals list, and that's going to take big O of n runtime. So in total, runtime for this implementation is going to be big O of n log n. And for space complexity, since we're storing this result in this result list, and in the worst case scenario, when none of the intervals are overlapping, then the result list is going to be the same length as the input intervals list. So the space complexity for this implementation is going to be big O of n. Alright, so that's it for today's question. I hope you enjoyed this video, and feel free to try this out on LeetCode or on your own, and feel free to post any questions, concerns, or comments in the comment section. I'll see you in my next video. Bye!